Hello everyone and welcome to another AP Computer Science video. This video is going to start a new topic for our second semester, and this is probably one of the more powerful and important topics we'll discuss in the class, mainly because it brings in a new idea where instead of keeping data individually, which is something that we can do and we've seen many times already, we can now start to merge data together, keep it data that's related to one another in one area, and this gives us a lot of control. But with that control gives us the responsibility of not just accessing a single variable, but having to potentially use iteration, loops, while loops, and for loops to access multiple pieces of content at the same time, or one after the other. And so this repetition, the idea of iteration, is a huge tool in holding information, accessing information, doing all kinds of things with it. But we're moving into pretty big ideas now, and this is a good thing, and it'll give us a lot of control and examples. So our video is going to focus on the beginnings of arrays in Java today. So I'm going to make a new package. We've had packages that have just kind of common things. We have our package for the basic information, class design, control, which was if statements, and if else's, iteration. We did our loops. So we're going to make a new package. So I'm going to right click on source packages or on the project and do a new Java package. And we'll call this one array stuff. I'm going to say array stuff just because I do believe that array, I don't know if it's lowercase or uppercase, but we do have to be careful because array and arrays are classes that may exist. So just to make things easy for ourselves, I'll call the package array stuff, just so there's no conflicts on accident. So within this package, we're going to make a class. So again, we're going to start how we always do, which is going to be making a simple class with the main method. And we'll do some small examples, create arrays, declare variables, and then we'll kind of grow from there. Let's make a new class. So a new Java class, and we'll call this array example. So array example 1. And there's our class declaration. And so we're not making a class to represent something. This is not a data class. This is instead just a main class. We'll just have our main method. So let's do that. Let's do public static void main. And now we're kind of closing in on finally knowing every single detail of our main method. We saw the access modifiers. We've seen the static keyword in the context of methods. We've seen the void return type in methods. Main is a name. And finally, we're going to start talking about what these brackets mean. Right? We've seen parameters passed into methods, but now these brackets is the final step. So once we talk about arrays, we'll now be able to say we understand every single aspect of the main method description or signature, and that's a good thing to have. So the first thing we should talk about is what is an array, and if you think about the word array for a minute, you might have heard it in different kind of contexts. I know the example I always like to think about is if you've ever seen like a sci-fi movie that's about space or involves satellites, you might hear like an array of solar panels or an array of satellites, a collection of multiple items typically related, right? When we say an array of solar panels, typically what it is a bunch of solar panels connected to each other. And then they all absorb some light, and they all transfer electricity from that light into some system, and that's where the energy comes from. And so in our case, an array is, again, simply going to be a collection of data. And our arrays are going to be able to hold basically any kind of data, including primitive and non-primitive data. So integers, doubles, booleans, things like that. But then also complex objects like the classes that we've written. So maybe we have an array of bank accounts. So now we can have many bank accounts. Instead of making individual variables, we could have one variable that represents multiple items. Maybe we make a student class. Maybe we make a grade class that represents a grade and a subject. And now we can have multiple grades, things like that. And this kind of gives us a lot of flexibility. So we're going to go ahead and start that. So let's put some notes. We'll put array collection of 0 or more items related to another single. Right, so the advantage that we're going to gain, because we have the ability to make multiple variables, and so you might argue, why do I need an array? I can hold multiple pieces of data just in separate variables. The idea of an array is to have a single data type and multiple items or values under one label. And so the advantage is I can say, you know what, maybe I have a collection called grades with an S. I name it with the plural just so it's easy to remember. And I can say, give me the first grade, give me the second grade, give me the 8th grade, the 9th grade, and so on. So I have a collection of many, many grades instead of maybe making individual variables, grade 1, grade 2, grade 3. And so that flexibility. Because the reality is we know once a program's running, you can't change source code that we've written while it's running. We can go and edit our code and then recompile it and then run it, and that's okay, but you can imagine that if we don't know how many grades are going to be put in, then we can't guess how many variables to make. Or we could make a bunch, and then that's a lot of wasted space. We don't use them all. And so an array is going to allow us to relatively flexible. It's not perfect. It's not the best solution, but it's a pretty good solution. But maybe to be able to flexibly say, okay, I need this much space. I need this many kind of variable locations to keep track of data, and then we can put that data however we want. And so let's start off with the first thing. Declaration of arrays is very similar to the declaration of any other variable. So we'll say array, right? So it typically requires one data type, and it doesn't have to be primitive, right? It can be a complex object class type, or and that's good. But we'll start off with primitives just because it tends to be a little bit easier. And a variable. A variable name. So this is very much a declaration. And so the one key difference is, and I'll put it in quotes, bracket notation. And I say bracket, and again, I remember at the beginning of the semester, I kind of had an example of parentheses, curly braces, or braces, and brackets. Brackets are those square ones. So now we're going to see them in a more meaningful way, along with bracket notation. So here we go. So declare an array. Well, we have to be more specific. A variable that may refer to an array of integer values. Now we're going to have to probably draw a diagram to be more explicit about what this means. We're not necessarily storing individual values directly, but a collection of these things. So here we go. So our data type is int because I want to hold whole numbers. This is my example in integers. There it is. And now immediately what changes, the first new thing is if I just put int. So if I just did int and said numbers, even though the variable name is plural, numbers, it might imply there are many numbers, there is only one integer value that's stored. So that's not really an array. That's not the intent of what we want. So we're kind of confusing ourselves, and this is why variable names are so important, is it's kind of a lie to suggest there are more than one number here by calling it numbers. The solution is to add that bracket notation. So to make a variable from a single value to an array of values, we use bracket notation. So after the data type, we put an open and a close bracket notation. Typically, the Java standard says the brackets are after the data type. I think, and I'll do it and test it, so I'm going to say Java standard is after type, but I also think we might be allowed to do something like, and it doesn't complain. So the reality is, as long as either the data type or the variable has a set of brackets after it, we know this is not a single integer value, but an array of integer values. And the reason that I think this is the standard is because if you were to just look at the type is no longer just int, but int bracket. And so that would put in our minds, oh, an integer array. If you replace these brackets in your mind with the word array, then here we're saying an integer array. Here, even though it's still the same, you might argue, well, it says int, and then you have to go, oh, it's also an array. It's not a single int. So it's, in my opinion, a much better situation to follow the standard. And again, it won't make code wrong, and I don't think the AP exam graders care because they're both technically syntactically correct. But the standard, and if we're trying to follow the standard, which we're doing for a lot of things, is to make the brackets after the type. So I'm going to go ahead and I'm going to comment it out, and I'm going to go ahead and leave it here and say we can technically do that as well. So now a declaration, we have to remember, is just asking the computer for space. It doesn't actually fill in values. Just like when we say int x, there is no value to x. There might be a default value, but we don't have control over that, and we don't know what it is. And sometimes there is no default value, and we get errors and warnings and things like that. So for an array, it's the same problem. Now, unfortunately, there is a technical reality we have to be aware of, so I'm going to put a note here. Even though it may look like this array is a collection of primitive values, and it is, the array itself is not primitive. It's actually kind of in between worlds. It's an object. It's a complex object. It has a potential property in it, unlike a primitive that's just a literal value. And so we have to be aware that because it is not primitive, we must ask for RAM to store the object. So we're going to be using the new keyword just like with our constructors for our classes. And so when we initialize a value, it's a little more complex than saying, oh, it's equal to 5, because it's not a single number, it's potentially many numbers. So we're going to go ahead and put that note. So initializing an array is a more complicated thing, so initializing. Okay, so there are two ways to do it. The first way is assign a literal array value. And this is convenient, but limited because it's kind of like, well, if you know the values ahead of time, it's not a bad idea. But if there are many, many values and you don't necessarily know them all, then it's not a good idea. Or if there are hundreds and thousands of them, it's not a good idea to do it manually or literally. Here's our first thing. We're going to go ahead and say numbers is equal to, and how do we assign a value, a literal array? So I'm going to put it here. Literal arrays are a set of curly braces with comma separated values inside. Right? So as an example, if I want to make an array that contains the values 2, 4, and 6, then I'm going to put a set of curly braces and then 2, 4, 6, and there it is. So that is a literal array value. And I realize there's an error immediately here, and we have to read this because, unfortunately, it would be nice to be able to do something like this, but there is one key component missing, and it is a very specific thing because of the literal value. And unfortunately, the error does not really help us understand exactly what's going wrong. This is not a statement. It's kind of weird because I'm making the claim that you can make literal arrays, and it says like semicolon expected, but there is a semicolon, so this is not working. And so the answer here is that, unfortunately, if we're going to make it a literal array, we must do it in one line. We cannot declare a variable and then give it a literal value in two separate lines. So instead of using numbers, let's create a new variable immediately and assign it. So if I say int brackets, because it's an array, and I'll call it other numbers, now notice there is no error. So unfortunately, literal arrays, and so I'll add this note now, you can make them, but if you're going to make a literal array, it must be done in the same line as the declaration. You cannot give a literal value to a declared variable that exists beforehand. So let's go ahead and put that. Right, so literal array values can only be assigned in the same line as a declaration. And this, again, is kind of a limitation, but if you're in a scenario where you know the content, in this case 2, 4, and 6, it's very simple, small, 3 values and that's it, then it's not a big deal to do it in one line. And often we tend to make objects and assign values in one line because it's easy and it's shorthand. Right, so this is a literal value. This is okay, and this is good for a small subset of scenarios where we know the content, we know that there's a limited size or spaces that we want available. And so what I'm going to do is, before we go to the next way of creating an array, which is the more flexible way, we have to kind of maybe give ourselves a little picture of what this might look like. If you've ever seen maybe lawyers, I think those are people that typically use them, but maybe teachers and other people, maybe you've used one of these accordion folders where there's a bunch of slots. I wonder if I open up Google and do an accordion folder, we can see a picture so you know what I'm talking about. Yeah, here we go. These I think are good pictures. You can imagine that this is, so if we argue, this is like one folder, but there are many, many subfolders. And you can see that we're saying, okay, well, essentially what you can imagine in our head, when we create the array, what we're doing is we're creating a folder, and when we make a literal one, we're saying there are 3 individual sections, and these are the values, 2, 4, and 6. But we're going to be able to instead say, create one of these folders, this array, but I want this many slots. So like in this one, there are many, many slots, maybe 30 or more. And in all these different pictures, there are kind of limited amounts of space. But the point is that it is a collection, and we could argue that they're all one unit. And so in our head, we could imagine this as our array. When you create an array, you're saying, give me this accordion folder, and I want it to have this many slots, and I can fill in the slots. Here we've done 2 steps. We've said, give me an accordion folder with 3 slots, and fill the slots with these values. And that's a convenient thing to do. And so when we make it the second way, we're going to instead do the opposite. We're going to say, I need one of these folders with some number of slots, but none of the slots are filled in, and it's our job to fill them in with whatever we like. So we don't necessarily get the best of both worlds. And we could use literal arrays for a lot of scenarios, and I could put as many as I like, but you can imagine if I had if I wanted the numbers from 1 to 1,000 in my array in that order, am I going to literally type out 1 to 1,000? That would be really tedious. So instead, we'll use the other way and a loop, and that'll allow us to fill it in. So let's go ahead and try our second version for creating an array, and so an array object. And so the way we're going to do this is we're going to use the new keyword to dynamically ask for RAM. So we're going to say use the new keyword. I'll put it in quotes so we remember that it is in fact a keyword to ask for array. Slots, right? So the idea is that we're saying, look, when we make this thing, we have to use a new keyword, and we're going to have to tell how many spots are required. So I'm going to go ahead and be explicit. The number I should say spots, not slots. Desired must be given, right? So you can't create the array in this second fashion without knowing how many spots you want. You're not allowed to say, give me one of these accordion folders and not know how many individual accordion folds you want, right? In this case, the reason we don't do it is because it's kind of obvious to the computer once it counts how many literal values you gave it. So here we go. We're going to do this. It's going to be the same thing. We're going to say numbers, and now we're going to be able to use numbers because it isn't a separate thing. So there's the declaration. Here's the assignment. So there's our new keyword. And now here, since there is no constructor, it's not like a class that we've made ourselves, so it's not going to be called bank account or security bot or student or anything like that. It's going to be the data type of the array, which in our case for numbers is int. The bracket notation again, so open and close bracket, and then inside those brackets, an integer value, either a variable or a literal, that represents how many spots that we want. So in my example, I might say 5, and there it is. And so if we were to write down what we've done, we can say we created an array that can hold 5 integer values. And so there it is. Now again, that's as if I created 5 individual int variables, and that's okay. But the advantage here, one, is there's only one variable, so the code is a lot shorter. And it's really easy to change how many I want simply by changing this number. I put a literal 5, but maybe we could tie it to a variable that's typed in by the user. And we'll do that in another example soon, where we can, this is where the dynamicness is really powerful. We can say, well, how many items would you like? 22, so we make the size 22. Right? So the size of the array, how many slots are in it, must be known ahead of time. You cannot construct an array in Java without that. You need to know how many spots. That's definitely a limitation. If I delete this, we can see the error pops up and read it. Array dimension missing. It says, look, you cannot be, it says that you're trying to make an integer, a single integer, and trying to put it in an array reference in a variable that encodes an array, and that doesn't work. So you must put a numeric value, either literal or a variable value that's of type int. You can't put decimals. I put 5.5. Of course, the argument is you can't make half of a slot, so it doesn't work, right? So it must be type int. So we're going to say 5, or whatever number you choose. And so now the next thing is, well, how do I fill in the values? Right? There's two different sides. How do I see what's inside of these in this folder, and how do I fill in the folder? Again, conveniently, the literal gave us the values and put them in immediately. So there's 3 slots, and we stuck in 2, 4, and 6. If I wanted to put these numbers 2, 4, 6, 8, 10, then I would have to go to each spot. So now we're going to talk about the two sides to either assigning a value to an individual spot or retrieving it. Because again, by making an array, it's not as easy as simply saying, oh, numbers is equal to some value. Because numbers is not a single item. It is a collection or group of items. So let's go ahead and talk about doing that. We will say, arrays. The format is really simple, and so we're going to say array name. We use bracket notation. So array name at index is equal to value. Right, so that's the format that we'll typically follow. So let's do an example. So we also maybe want to ask the question, well, if we didn't fill it in, what's inside of this array? Like in our real world analogy of that folder, when you open up the accordion, there's nothing in them. But unfortunately, we can't really say that's true for Java. That kind of analogy breaks down because we're not in a physical world in this code. And so often, for primitive values, arrays have some default value. So for numeric values, integers and doubles, the value is 0. If you look at an array spot and you haven't put something in it, it's going to contain 0. So this array actually contains 5 zeros within it. This array doesn't. This has 3 spots and it has 2, 4, and 6. But a default array, and if we made an array of booleans, I believe the default values are falses. So if you made an array of 10 booleans, you'd have 10 falses. If you made an array of chars, I'm not sure what they put as char values by default. We could probably test it, but that's kind of outside the scope of this video. For non-primitives, for class type variables, so if we wanted to make an array of scanners, or an array of strings, or an array of bank accounts, the default value is a null reference. And if you don't remember, that null keyword basically means don't point to any RAM. So you can't refer to it, otherwise you might get an exception, a null pointer exception that could cause problems. And so we have to be careful of using an array without making sure that we've assigned values. For primitives, it's safe because there are default values. For non-primitives, for class types, it can be dangerous. So we have to make sure that we're aware of that at all times. Right? It's a multi-step process. Create the variable, construct the object with the new keyword, and then potentially assign and look at values. So here we go. Let's go ahead and say, I want to fill in the first spot of the array with the number 7. So I'm going to refer to a spot by using what's called an index. And so we already know this idea of indexing with strings, right? With strings, we said every character in a string has a number associated with its position, where the first one is always 0. This is in fact also true for arrays. So this is, that's my phone, I should have put on silent. So the reality is that if we want to refer to an individual spot or assign an individual spot, we give it an int value that represents the location in the array that we want to affect. And so, for example, the first spot would be the name of our array is numbers. We're going to use bracket notation. And then we're going to say, well, I want the first spot, the first item or first spot, if that first slot in our folder is slot 0. So we're saying numbers at 0. So you might hear the word at or bracket, or so like some people say numbers sub 0. That means the first spot 0. Some people say numbers, so we might say numbers sub 10. And that's the 11th spot, because if we start at 0 all the way to 10, that's the 11th spot. I and many people also say at. So I'm saying numbers at position 0. So you might hear bracket notation, you might hear sub notation. And so typically I use the word at in English to represent the location. So numbers at position 0 is equal to some value. And of course now the value type must match the type of the array. So it has to be an int. If I try to put a boolean or a string or a double, it's going to fail unless I do some kind of casting. So I might put the number 7, like I said. And there it is. So now the first position is value 7. And let's go ahead and fill in the last position with the value. So right now, if we were to look internally, we should have 7 and then 4 zeros, because the other subsequent spots, the 4 spots that we haven't touched, have their default value, which should be 0. So numbers, and now here's the question, what index is the last spot? We think about it just like a string. What index is the last spot of a string if you know the length? And so here we know there are 5 slots in our folder, or 5 spots in our array, so what is the last index? If we start at 0, the last safe index would be 4, right? Because the 5th spot is index 4. So here we can say it's equal to 10. And so assigning a value to an array is easy. We cannot do something like this. And I'm going to write it just to show it, because this does not make sense. And so if I say something like, this is a problem. And this is a pretty easy error to understand. It says incompatible types, int cannot be converted to int brackets. It says, hey, numbers is a reference or a variable that can hold an integer array. You cannot assign a single int to an integer array variable, right? Just like you can't assign a single string to a double variable. The types don't match. But when we use the bracket notation, we're saying, hey, open up that accordion folder, go to spot 0, go to spot 4, and then slot something inside of there. That's what matters. So this kind of line does not work. If your variable is an array, you must use the bracket notation. And the same applies for printing the values. So for example, let's try to prove this. So we'll say, let's do a nice little print message, and we'll say spot 0, spot 0 of the array contains. Now let's attach, and now to access from an array, the same logic applies. So we can say we still use the bracket notation. So the format is basically array name at whatever index we want. And again, how does it know whether to retrieve a value or set a value? If the bracket notation is on the left of an assignment, then it's probably going to be that you're changing the value in the array. If it's on the right side of the assignment or not in an assignment at all, then it's typically going to be an access. So in this case, I'm saying, well, I want to show the value inside the spot. I don't want to show the 0 unless that happens to be the value. I want to go to the array numbers and look at a particular spot. Again, when I put brackets, I'm going to use that word at. And so spot 0, and there it is, right? And now if I ran this program, we expect to see, well, actually, let's be more specific. Let's say of numbers array, then we should see the value of the first spot, which after the assignment should be 7. So if I run it and we see our code go, we should expect to see the value 7 displayed. And we'll do it again, but we'll use other numbers and see. And there it is, right? The index, which is the location, is not the same as the actual value itself. So let's go ahead and copy this real quick. Let's try it again, but now I'm going to call it the other numbers. And I'll refer to other numbers. And there it is, right? Other numbers was this literal array. So if I run it, nothing much has changed except the actual, and there it is, right? Because the first index, the first slot in our array contained a value 2. And there it is, right? And of course now we can do many other things. And now there is a risk, and I'm going to do it on purpose to break it because there is a danger here. If we know the size of our array, which we have to, or someone has to protect ourselves, and I'm doing it kind of one line at a time. We'll write more code with loops that do it a little bit better, but essentially, if we have the size, we can't go out of bounds. First of all, negative indices do not work. That'll cause an exception. And indices that are larger than the last saved index. So if I put the number 8, that would imply I'm looking for a 9th location, right? Because if the index is 8 and it were valid, then that would be at least 9 spots, right? Because starting at 0 to 8 is 9 indices. There are not 9 indices, there are only 5, so that means this is going to crash. And we should get, I believe, an array index out of bounds exception. It's a big name, but there it is. It says array index out of bounds exception. It says, look, you tried to use index 8, but the length was 5. It says we have only 5 slots. There is no 9th slot or slot number 8. Therefore, this program crashes. So we have to be very careful. And notice that this is a runtime exception because notice how the other 2 lines ran normally and they were effective. And then as soon as it caught to the scenario, so there's no syntax error because it's not smart enough to spot that this is out of the size. And so it's our fault and it's a runtime exception, specifically an array index out of bounds exception. Right, so this is definitely a danger that we have to face to make things work out better. So I believe I'm going to stop the video here. And our next video will do the big thing, which is merging the usage of arrays with loops. Because at the end of the day here, it's great, but am I going to copy this? Let's say I want to print out all 5. Am I going to duplicate this thing 5 times and put 0, 1, 2, 3, 4? I mean, I could. It's only 5 spots. But now you say, well, actually, I need to keep 100 numbers. Or I need to keep 7,000 numbers. And those may seem like big numbers arbitrarily, but it's perfectly reasonable. You think about the number of people that go on and Google search an item. There are literally billions of Google searches, or maybe not billions, but millions and millions and millions of Google searches every day. There are millions and millions of people accessing Instagram every day. And so the idea that we have like sets of numbers that need to be contained, passwords and usernames in the millions is perfectly realistic. So we should have code that's flexible enough that we're not going to hard code a bunch of individual prints. We're going to use iteration to speed things up. So the next video, we'll see how we can retrieve values from arrays, display values from arrays, access the content in a very dynamic, flexible, and safe way. So I'll see you in the next video.